Well, good evening. Wonky Astronomer here, coming to you from Hazelbrook Observatory, or the Hazo Gazo as I call it. And normally I'd prefer to be doing a live viewing of the sky through my telescope, but as you can see from the sky camera, we have a lot of cloud. This is a camera pointing straight up at the sky that's showing you the last few hours. And so tonight I'll be showing instead some pre-recorded images, but it should be almost the same as a live show. Now we've got 15 viewers at the moment. Let me know in the chat where you're from, and you can ask any questions. Thank you. Yes, the music is from the YouTube library, so it's hopefully free of copyright. Now we might just get straight into it and start with the wait a minute, straight to the first object in our list. So let's go to our planetarium program, and I've got a list of the running order. Got it on this scrap of paper here, but I'm hoping that we'll get totally sidetracked by your comments and questions. We'll go off on a tangent, may even descend into chaos. Now I'm assuming you can all hear me. Should let me know in the chat if you can hear me, because otherwise I'll be going on and you won't hear me. Alright, so let's get to the first object. First we're going to look at some galaxies. So Paul, Lower Blue Mountains. Yeah, I advertised this stream in a few of the local Facebook groups. And no one's saying they can't hear me. Blaxland. And yes, I assume that means you can hear me. Excellent. All right, so let's get to the first object. First, we're going to look at some galaxies. So the first one on the list is the Sombrero Galaxy. Now, as you can see from that chart, it's actually below the horizon at the moment. So what I might do is turn off that horizon so we can actually see it. This is one of the advantages of doing a non-live viewing. You can oh, it's telling me the space station's rising. We can't see that. Yeah, non-live viewing, we can look at things that are actually below the horizon. So that's one advantage of cloudy weather. All right, so let's get straight to it and send the telescope. Well, not really, but send the telescope to the Sombrero Galaxy. Getting a few comments here. I'll send the telescope while I read some of these comments. Hello, Lou. I know Lou. Tonight was supposed to be our astronomy club observing night at Linden Observatory, but we had to cancel it. So I thought I'll do this stream instead. Seven Hills. Hearing well in Falco, that's Falconbridge, for those not familiar with the mountains. Can you hear me in Falconbridge? Excellent. And yes. Okay, so there is the Sombrero Galaxy. Wait a minute. Oh, Sarah, a new member. Sarath, sorry. A new member. Yes, I think I met you at one of our sessions. All right, so the Sombrero Galaxy. So this is a galaxy outside our own galaxy. It's in the constellation Virgo, and it's a spiral galaxy, and we're seeing it pretty much edge on. So that's why it doesn't look like a spiral. And it's about 28 million light years away. And the physical size is about 70,000 light years from side to side. So just a moment. My mouse, there it is, from side to side. And that's comparable with the size of our own galaxy. Our galaxy is about 100,000 light years across. This is 70,000, so a little bit smaller. Now, I'll show you a professional image of this galaxy. So the interesting thing about this galaxy is it has this very prominent dark dust lane that goes through the middle. And this is, a lot of galaxies have this, but on this one it's really prominent. So it looks quite spectacular. Now this was the first galaxy to have, Lou's heckling me here. Wait a minute. Can we zoom out initially to locate where the object is in each constellation? I hadn't planned on that. But anyway, alright, we can do that. Just a moment. So this is in the constellation Virgo. Wait a minute. There's Virgo. I've turned on the mythical figure display so you can see what the constellations represent. And the Sombrero is there. It's actually sort of between Virgo and Corvus, but technically in Virgo. Now, let me go back to that image. Hang on. Put Lou's comment up again. Lou sends a smiley face. Thank you. Another smiley face. So, and you can see there that the Sombrero is below the horizon. Wait a minute. There, it's below the horizon. That green part's the horizon. Alright, so this galaxy was the first to have a large redshift measured. That was by an astronomer called Slipher in 1912. And what that means is that this galaxy is moving away from us at a very high speed, at 1100 kilometers per second. And the measurements of galaxies moving away by their redshifted spectrum was the foundation of the Big Bang theory, because we can see that everything's moving away from each other. All the galaxies, well, not all, but all the galaxies that are beyond our local group are moving away from each other. And the further away they are, the higher the speed. So this was early evidence for the Big Bang. Now this galaxy contains a large number of globular clusters. We will look at some globular clusters later. I'll just show you a diagram of what I mean by globular clusters. So this is a diagram of our galaxy, and you've got these, you've got the disk of the galaxy here. It's a flat disk. Our sun is here, and pretty much all the things I'll be showing you tonight are in the general area of our sun, except galaxies and globular clusters. So galaxies, completely separate galaxies, similar to this one, and they're very far away. But globular clusters are these balls of stars that surround the galaxy in a sort of halo, and our galaxy has about 150 of them, but this galaxy, the Sombrero, has perhaps as many as 2,000. So that's unusual. Alright, so we might move on to the next object. What's next on our list? We've got another galaxy. Alright, so to make Lou happy, let's see. Well, I'll show you where it is in the sky. It's actually, this is M83 I'm going to now. And M83, or the Southern Pinwheel Galaxy, is in Hydra, and it's very close actually to the previous one. That's the Sombrero that we were looking at, and that's the next one we're going to look at, M83. Okay, so I'll send the telescope there now. Well, I won't send the telescope. I'll show you a video of me sending the telescope there. Now, I usually control the telescope from inside the house. It's fully automated. I don't like to go out in the cold weather or even the warm weather. So there is the Southern Pinwheel, or M83. We've got about 20 viewers now. They're gradually trickling in. And we'll zoom in a bit on that galaxy. It's almost like I'm doing it in real time, isn't it? So let's look at an image, professional image of that galaxy. That's the Sombrero. We'll go to an image of M83. There it is. Now, this is in the constellation of Hydra. It's another spiral galaxy, but this time we're seeing it face on, so we can really see the spiral arms. It's about 16 million light years away, and it's about half the size of the full moon in the sky, and its physical size is about 100,000 light years across, so that's almost the same size as our own Milky Way galaxy. So it's probably very similar in appearance. So this is pretty much what our Milky Way galaxy would look like if we could view it from the outside. Now, this was the first galaxy discovered outside our local group of galaxies, and this was in 1752 by de la Caille. And it's quite bright. You can see this in binoculars. It would just look like a fuzzy smudge in the sky in binoculars. And it has asymmetric arms. So if you look at these individual spiral arms, I think that one is quite long. There's one there that's perhaps shorter. And then I think there's a third one there, which is even shorter. So they're asymmetric. Now, there have been a number of supernovae discovered in this galaxy. Supernova is an exploding star which is at the end of its life, runs out of fuel and explodes and becomes very bright. And this galaxy is the has the equal second record for the most supernovae discovered in one galaxy, and that's 6. The record is 9. And you can see there are many areas of star formation in this galaxy. There are all these little red areas, lots of little red splotches, and they are areas of hydrogen gas or nebulae, where the gas will collapse and form stars. And a little later I'll show you some nebulae. Alright, so we've looked at an edge-on galaxy and a face-on galaxy. So now I'd like to show you a group of galaxies. We're doing lots of galaxies. And, okay. So Lou wants to see where it is. All of these are sort of just below the horizon right now. Actually, should be using the current time. Okay, so we're just looking at M83, which is there in Hydra, and now we'll go to the Leo triplet, which is in Leo. And it's just over to the left, where we were before. So I'll send the telescope, or I'll pretend to send the telescope to the Leo Triplet. Now this is a group of galaxies. As you might have guessed from the name, it's 3 galaxies. Now we're seeing white there because, well, you can see in that picture that the telescope's pointing at the inside of the dome. The telescope's actually already reached the target, but now the dome is catching up. And the camera you're viewing that through is mounted on the dome, so when the dome turns, it looks like the whole telescope's moving, but actually it's just the dome moving. So there you can see 3 galaxies. Let's have a look. These 2 bright ones here, they are called M65 and M66, and a third one up here, which is called NGC 3628. Now you may have noticed, actually all the objects we've looked at so far have got this M number associated with them, and that's because of an astronomer in the 1700s, a French astronomer called Charles Messier, and he was looking for comets. He liked comets, but he kept finding these little fuzzy objects, and he would watch them for a little while and see that they didn't move, so he thought, oh, these aren't comets. So he decided to make a list of them. So this is a list of the things that he didn't want to look at. They were annoying to him. So he made this list, and there were 110 objects in the list, and this is now one of the most popular lists of objects in the sky, particularly for amateur astronomers. And so everything in that list we call M something. So this is M65 and 66. Now Messier, he saw these 2 objects and gave them those numbers, but he didn't see this one because it's a bit dimmer. So that's why it doesn't have an M number. Instead it's called NGC 3628. So it was given that number much later. Alright, now I'll show you a nicer image of that. That's the previous image. Okay, so there's a more professional image. I'll just rotate that to match. Actually, I won't rotate it all the way because I want to show you something on that bottom galaxy. And that text gets in the way. We have someone called Australia from the Upper Blue Mountains, Lura. Yes, I used to live in Lura, and I later moved to Wentworth Falls and then to Hazelbrook. Yeah, so these 3 galaxies, they're at a distance of maybe 35 to 40 million light years, and the physical size of, say, this one, wait a minute, that one there, M65, is about 93,000 light years. So that's similar to our own galaxy, which is about 100,000. Now, all 3 of these galaxies show some distortion because they're in a group, they're actually physically close to each other, and their gravitational influence, they pull on each other. Tidal forces, just like the moon causes tides on Earth and distorts the Earth a little bit, these galaxies distort each other. Now, it's a little difficult to see on some of them, but they all do have a bit of distortion. This one is a little bit distorted, but I think it's easier to see on this one here, which is M66. You can see a little tail coming off it there, and a sort of an asymmetric shape. And the one over here is also a little bit of a funny shape. So that's very likely caused by the gravitational forces between the galaxies. Now, an interesting thing about that third one, NGC 3628, this one, is that the stars and the gas rotate in opposite directions. And that's very unusual because, you know, everything's rotating, these galaxies are rotating. Nice comment by Rob there. But in this one, the stars and the gas are rotating in opposite directions. So that probably means that that galaxy has resulted from the merger of two other galaxies. Now, Rob notes that Bob Evans discovered a supernova in M83 and M66. Now, Bob Evans is a famous astronomer local to Hazelbrook. I can actually show you a little bit, I'll show you his picture. One moment. Right, there's Bob Evans. Yes, he was a resident of Hazelbrook. He passed away 2022, I believe, and he discovered 42 supernovae. So as I mentioned, supernova is an exploding star, a star that's reached the end of its life, it's run out of fuel, and it explodes. And we find supernova, of course, stars are in galaxies, so we look in galaxies to find supernovae. Typically a galaxy the size of ours should have a supernova about every 50 years. Our galaxy hasn't had one, or one that we've been able to see, since I think 1604, and the telescope was invented 1609, so we haven't had one since the telescope since we've had telescopes, but we see them in other galaxies. So yeah, Bob Evans discovered 42 supernovae visually, and that's a telescope he has there, and you can see those black labels on the telescope, and they are little labels with the names of the supernovae that he's discovered with that telescope. And that telescope, we have that at Linden. There's another picture of him with another telescope, another list of supernovae. And he had an amazing memory because he could look at a galaxy and just recognize, well, almost immediately whether it had a new star in it. These days, supernovae are discovered mainly by automated systems, computers looking through images to find new supernovae. So his record of 42 with just by eye, looking through the telescope, is unlikely to be ever surpassed. Alright, now I might just show you, before we move on to nebulae, we've looked at galaxies, we'll do nebulae next, but before that I might just show you a little bit what my observatory is like. I showed you this image before, but I built this observatory in 2019, and it came in boxes in a kit. It's like an IKEA observatory. Bought it from a retailer in Melbourne, but it's made in Canada. And I assembled it on my back patio and put down a concrete slab. Those flower pots in the concrete there are making holes for the tripod legs. Here are the walls partially assembled. And put the floor down. And there's a telescope installed. Now, since that picture was taken, I've changed the mount, so it does look a bit different now. And there it is in my backyard. It's actually at the side of the house, so it is visible from the street. There it is. And so people passing by sometimes ask what it is. Alright, so now let's move on to nebulae. It's nebula time. All right, so let's go back to the realistic horizon, because I think the next thing we're going to look at will be above the horizon. So, Orion Nebula. This is, you can't beat the Orion Nebula.
It is a superb sight.
It's a superb sight, as you will see. Now, the Orion Nebula is in the constellation of Orion, which is the hunter, and there he is there. I've got the mythical figure turned on, and you've got his shoulders there and his feet there, and of course he's upside down because we are in the southern hemisphere, and so we're upside down, and that's his belt there, and then he has a sword dangling down. There's the sword, and on that sword is the Orion Nebula. So we'll send the telescope to that now. Well, as I said, I'll pretend to send it. Now this is one of the brightest nebulae in the sky, and you can see this with the naked eye, and it's a very spectacular nebula. So there it is, and we can increase the exposure a bit. And I think a bit more. Right, so we can see quite a bit of detail there. Let me bring up a better picture. So there's a professional photo. Now, this is an emission nebula. All the nebula I'm going to show you tonight will be emission nebulae. Now, an emission nebula means that it's emitting its own light. It's gas that's been energized by nearby stars, or stars that are within the gas, and it energizes the gas and it glows. It's a little bit similar to the way a fluorescent light or a neon light glows, where electricity passes through the gas and it glows. The mechanism is a little different depending on what gas it is. So this is hydrogen gas, so it's not quite the same as fluorescent or neon. But this is at a distance of about 1400 light years, and it's quite big in the sky. It's bigger than the full moon, and its physical size is about 35 light years across. Let me just see if the exposure increases. Oh yes, we can increase the exposure there. Now, this was the first deep sky object to be photographed, and that was in 1880. And that was done by Henry Draper with an 11-inch refractor telescope. Now that's the same size as my telescope, 11-inch. And I can show you that photograph. Just a moment. Here it is, and that is a 51-minute exposure, whereas the photograph you're seeing from my telescope, I think that's a 1.3 second exposure. So 51 minutes versus 1.3 seconds. So photography has come a long way since 1880. Now he did take another photograph a couple of years later. This is from 1882. That's a 137-minute exposure. You can see that the wait a minute, where is it? The photograph's been damaged down there on the left. It's actually that orientation is sort of the reverse of what you're seeing in my image, but and unfortunately I can't rotate that one. Now there's a cluster of 4 stars at the center of this nebula. You can't see them in this image, but it's sort of down here somewhere. And they're easily visible in small telescopes, and they are responsible for the light, or the ultraviolet light, that's causing the nebula to glow. Alright, now let's move on to another nebula which is very close. So let's look at Sky Safari there. So that is the Orion Nebula in the Sword. Now just up near the top of the Sword, just there, is the Horsehead Nebula and the Flame Nebula. Ooh, it's moving by itself. The Horsehead Nebula. So we'll go to that now. Now the Horsehead Nebula is quite dim. It's very difficult to see in the telescope. I've never seen it. We have tried to see it in the big telescope at Lyndon, the 30-inch telescope, but we've never succeeded. So there it is. We'll just move it into the center a bit. Okay. Now I'll show you a picture of that. There it is. I'll just rotate that. It may not be so obvious in my picture where the Horsehead is, but I think if you look at this one, and I put it in the same orientation, you'll be able to see where the Horsehead is. It's a dark nebula. So there's a nebula here, and there's a bit of dark material forming the shape of the Horsehead. So this is about 1600 light years away, and physically it's about 2.8 light years across. I'm not sure if that refers to just the Horsehead part, because there is a lot of other, all this is dark nebula as well. Now it's located near the bright star Alnitak. Now you can't see that in my image. I'll show you a wider image. Okay, so there's a wider view, and actually if we look at the view in the planetarium program, look at it in here, you can see the 3 stars of the belt of Orion, and the Horsehead Nebula is right near one of those stars, Alnitak. So it's near this very bright star, and you can see that star there. Now this is regarded as the most annoying star in the whole sky, because it's so close to these 2 nice nebulae, particularly the Horsehead, which, as I said, is quite dim and hard to see. So this star Alnitak just gets in the way. It's glary, people don't like it. It's a very unpopular star. Now one thing to note is the difference in the number of stars on the 2 sides of this dividing line. So this line here on this side is a normal nebula. It's glowing, and there's quite a lot of stars there. On this side, not so many stars, because that's a dark nebula blocking the stars, and a bit of that dark nebula protrudes across to form the Horsehead. Now there is this other nebula near it. You can see it in that picture, in that wide picture. That's the Flame Nebula. So I'll send the telescope to that now. One moment. We have a question from Lou. What are the specs of your scope? Are all the objects you've been showing photographs involving time exposure? Well, That's a good question. The scope is an 11-inch scope, and I've got it set up with a focal length of 560 millimeters, which is quite short. So in photographic terms, that's f2. And regarding the exposure, as I mentioned with the Orion Nebula, that exposure was about only 1.3 seconds. So when you see the telescope move and land on the object, and you see the image appear, that's how it really happened in real time. So if this was live, it would look exactly like that. So it's very short exposures, and that's because, well, I'm actually using two different cameras. Some of these recordings were made with one camera and some with another, but the main camera I use is the one I use for occultation observing, which is very sensitive. But the other camera is also quite sensitive, so we only need very short exposures. Now, of course, if you wanted to bring out more detail and more improve the signal to noise, make it sharper, you would use longer exposures and stack many exposures like astrophotographers do. Alright, so the Flame Nebula that we have there, let's go back to that image. Do I have a better image of the flame? There's a different angle, it's a wider view. The Flame Nebula is this one here. And in fact, I think in this image you can see two stars of Orion's belt, these two. All right. Now, next on the list is clusters. But before that, I think I might just show you what my stream setup is like here. How am I doing all this? Let me bring up a wide-angle view. This is my setup. Hello. So, as you can see, I've got a lot of screens, and I've got my main computer here. I've got my notes on there. See, I'm reading all this from notes, so I don't remember all this stuff. And I've got my streaming software over on this computer or this monitor, so I can see what you're seeing. And in front of me here, I've got where I'm playing the videos. So that's the image from the telescope, and that's the image of the telescope. And at the top there, I've got some details about each video, which you can't see. And then on this screen, I've got what I call my scratch. It's my scratch screen, which is where I put stuff that is then captured by the streaming software. So for example, up there is my all-sky camera view, which you can see, well, just over there. And here I've got my stream deck with buttons where if I push one of those, for example, I'll bring up the all-sky camera by pushing this button, and I can play sound effects, or if something goes wrong, I'll play this one. Alright, so let's move on to clusters. Clusters. So there are two main kinds of clusters, and I'll show you the good kind first. So first we'll go to M22, which is a globular cluster. I'll zoom out a bit and we'll see where it is. M22. Thanks, Barney. I know Barney. Oh, M22 is below the horizon. I'm surprised. Wait a minute. Yes, okay. I'll turn off the horizon. Just get rid of the horizon so we can see it. Okay, so M22 is in the constellation of Sagittarius, a very well-known constellation. The center of our galaxy is in that direction. think, right, this doesn't show the Milky Way very well below the horizon. But okay, we'll send the telescope to M22. There it is. Oh, I didn't show you the telescope. Okay, and we'll zoom in a little bit. There you go, zoomed in. So M22 is a globular cluster. Now I showed you before, I'll just bring that up again. Wait a minute. Globular clusters. These are balls of stars from perhaps, you know, up to a couple of million stars that are in a ball. Oh, my all-sky camera has crashed. Oh, there it is. Yeah, so this is the disk of our galaxy, and we've got these balls of stars called globular clusters that are all around it in a sort of halo. It's not well known, you know, how they came about or where they came from. They're like very, very small galaxies, and they usually contain very old stars. So this one is called M22. Another one that's I'm not sure if it was discovered. Yes, first discovered 1665, so not by Messier, but he did put it in his list, which is why it has an M number. And it's one of the brightest globular clusters in the sky. It ranks third. There are two that are brighter, and they're both in the southern hemisphere. This one's also in the southern hemisphere, but a lot of northern hemisphere people could see this because it's not too far south. And it's one of the closest globular clusters to us. It's only about 10,000 light years away. Now remember that our galaxy is about 100,000 light years across, so this is a tenth of the width of our galaxy away from us. And it was one of the first discovered, as I mentioned, in 1665. And an astronomer called Harlow Shapley studied this in 1930, and he counted 70,000 stars in it. Now I don't know how he did that, whether he counted them one by one or made an estimate. But the modern estimate is that this contains about 500,000 stars. Now, as I said, this is the good kind of cluster. The other kind is the open cluster, which I'm not so fond of, as Rob knows. But there are some nice open clusters as well. So I'll show you an open cluster. This is a very popular open cluster called the Jewel Box. Now let's zoom out, and we'll go to the Jewel Box. We'll see where it is. The Jewel Box is there. It's actually in the Southern Cross. Southern Cross is the smallest constellation in the sky. Now currently the Southern Cross is sort of on its side. There's the cross there, and there's the Jewel Box. So I'll send the telescope there. Show you the dome there. You can see through the dome there our bathroom window with the light on. Now you can see the bricks of the house. And the light from the house doesn't really interfere with the telescope too much because it's quite well shielded, so it doesn't cause me too many problems. Alright, so there is the Jewel Box. Oh, wait a minute. I let the video play too long there. So the Jewel Box, Now the jewel box is an open cluster. It's about 6,400 light years away from us, about a third the size of the full moon, and it's close to the star Beta Crucis in the Southern Cross. So most of you are probably familiar with this. The flag has the Southern Cross on it, and don't worry about that other star, that's not a real star. But if we zoom in on Southern Cross, that's where the jewel box cluster is. Now what we can do actually is move the telescope a little bit, move it a little bit more, there it is. And you can now see there's the jewel box, and there is Beta Crucis, which is that bright star. It's that star in the Southern Cross. So the jewel box and Beta Crucis are quite close together. Now, why is it called the jewel box? Well, John Herschel, who was an astronomer, lived from 1792 to 1871, described it as a casket of variously coloured precious stones. So that's why it's called the jewel box. And looking at this colour picture, actually there's a better one. You can see, now this cluster contains about 100 stars, but most of them are blue giants. But the fourth brightest star in the cluster is this very distinct red star, which is a red supergiant, and that's the central jewel in the box. So that's why it's called the jewel box. And it's also a very young cluster. It's only about 7 million years old, which is very young for pretty much anything in astronomy. Now we've looked at galaxies, we've looked at nebulae, and we've looked at clusters. But I usually don't use my observatory to look at any of those things. Lou says, note to new members, reverse telescopic image. Right. Is it? I think my images are not reversed. They could be. Some of them could be. It actually depends on a number of things. But I think, for example, that one, that one you're seeing there, I think that's the right way around. Australia says it's beautiful. Thank you. Lou says question. What are you trying to say, Lou? Now, well, maybe what Lou's referring to is that when you look through a telescope, some telescopes will reverse the image, so you may not see it the same way around. Telescopes have mirrors and lenses and things, and depending on how many mirrors there are, or what the optical configuration is, it may reverse the image. So yeah, sometimes you'll notice it, particularly with the moon. If you look at the moon through certain types of telescopes, it'll look upside down. I tell people, when they look through my telescope and they say, "Oh, it's upside down," and I say, "Yeah, that's because we're in Australia," and they believe it. All right. So as I was saying, we've looked at galaxies, we've looked at nebulae, and we've looked at clusters. But I don't normally look at any of those things with my telescope. What I mainly use the observatory for is something called asteroid occultations. That's what I do most of the time. So I thought I'd show you an asteroid occultation because it's quite an interesting thing. All these other objects you look at, they're static. They don't change over many years or many decades or even centuries. They look pretty much the same. But with an asteroid occultation, you will actually see something happen. So, yeah, I don't have a picture of the telescope for this one. So what happens with an occultation? Just a moment. Well, first of all, what is an asteroid? You got your asteroids, you got your comets, meteoroids, and dust. So dust is very small stuff, as you would expect, as the name implies, tiny particles. And then you got your meteoroids. They could be just small rocks up to a meter in diameter. So they're just rocks floating in space, orbiting the sun. And then you've got asteroids and comets. And they are bigger rocks. Asteroids from 1 meter up to a few hundred kilometers. And comets are similar size. But the difference between asteroids and comets is that comets give off dust and gas when they get close to the sun, and they get warmed up and give off this gas and dust, and that's why comets have tails, particularly when they get close to the sun. Whereas asteroids are pretty quiet. They don't give off anything. They're just either rocks or piles of rubble, like gravel, all stuck together. So what happens when an asteroid is just moving along and it passes in front of a star? Well, if we're looking at the star when that happens, it will look like, wait a minute, like this. That blue line represents the light of the star, and an asteroid comes along and hides it, and the starlight drops. Now typically the asteroid is difficult to see, they're quite dim, so you wouldn't actually see the asteroid like you do in that animation, just see the star typically, and so you would see the level of the light drop. So I'll show you now an asteroid occultation, what it really looks like. So if you watch this star, keep watching, and it's gone because the asteroid's covered it, and it comes back when the asteroid moves past it. And so by observing these, we can actually do some real science. We can learn things about the sizes and shapes of asteroids, and even detect things like rings around asteroids or asteroid moons. All right. Now, next on my list, I've got my running sheet here. Next it says random stuff. So I think that just means whatever's next. So next on the list is another nebula. This is quite a nice one, the Carina Nebula. Now we're looking here at the jewel box. We're at the jewel box in the Southern Cross. Now the Carina Nebula is very close to that. Carina Nebula. There it is. Carina is the constellation of the Keel. There's a ship. I don't know if you can see that ship. I think that's it there. And there's several constellations that make up the ship. So I think Carina is the Keel. I could be wrong. I don't know much about constellations actually. All right, so let's send the telescope to the Carina Nebula. This video is actually sped up a little bit. It doesn't actually move that fast, but it was a long slew, so I think I sped up the video a bit. Good morning, Rahul. Good morning suggests that you're watching from somewhere other than Australia. Okay, so there's the Carina Nebula. Now let's. I'll actually show you an image that you might have seen in the media. This is an image from the James Webb Space Telescope, which was released. It was one of the first images to be released from the James Webb Space Telescope when it was when it first became operational in, I think, the middle of 2022. They released I think 3 images. This was one of them. It's known as Cosmic Cliffs, and this image is in, well, it's sort of in the Carina Nebula, maybe a little bit off to the side, but I'll show you where that is shortly. But I'll just show you a professional image of the Carina Nebula. Now this is also an emission nebula like the others I showed you, which if you remember, it means the gas is glowing, and it's about 10,000 light years away from us. And this is also visible to the unaided eye. It's quite bright, and there is a dark nebula in the center called the keyhole, and that is in here. And right next to that is a bright star, Eta Carina, and this is a very significant star, which I'll talk about in a moment. Now, it's well, I'll tell you about that star now. The star Eta Carina is one of the most massive stars known in the Milky Way. It's not the most massive, but it's one of the most massive, and it's about 150 to 250 times the mass of the Sun. And in 1837, this star had an outburst, making it very much brighter than it was before. It was barely visible to the naked eye before, and it became one of the brightest stars in the sky for, I think, several years. And the remains of that outburst can be seen if you zoom in on this very small area around that star. You can see this. Now this is called the Homunculus Nebula, and it's the gas that's been blown off by that star when it had the outburst in 1837. And we can see this in medium-sized telescopes. It is a very small object, so you need a bit of magnification to see it properly, but it is quite interesting to see that. Now, also the Keyhole Nebula, which is that that bit there. I'll show you a close-up of that. There is the keyhole. The keyhole there. Doesn't look that much like keyhole, really. And there is Eta Carina, the star I was talking about. Now, I'll just show you a few other close-ups of parts of this nebula. Now, I'm not sure exactly where these are, but I think these are made by the Hubble Space Telescope. This one's called the Finger of God, for obvious reasons. Now this one is called Mystic Mountain. Very nice colours there. This is a star cluster called Triplet 14, and that is actually, if you look on my picture, that's, I think, around here. That is that star cluster. But getting back to the image from the James Webb Space Telescope, I'll show you where that is. It's actually, in my image, unfortunately, it's a little off the edge. It's not quite in the frame, but I've got an image here that shows you the context. So up the top, just off the edge there, is this little nebula, It's actually got a different name, NGC 3324. So technically not part of the Carina Nebula, but I mean really it is part of it physically, I think. And if we zoom in on that little area, we get this. This is a close-up of that area. And then we zoom in on that bit, we get this. And if we zoom in on that bit, we get that image Cosmic Cliffs by the James Webb Telescope. So it's a very, very small area that's shown in that image. I encourage you to go to the NASA website and view that image in high resolution, because there's a lot of detail in there and it's quite spectacular. All right, no more comments. All right, I think what I'll do now is we've been going for an hour, so I think I'll sign off. But what I'll do is after I sign off, I'll let the stream run a little longer, and I'll show some pictures of the moon, so with some soothing music in the background. So thanks everyone for watching, and if you do have any other questions, you can put them in the comments of the video and I'll get to those later and try to answer them. So good night, and come back next time.